Good morning, good afternoon, good evening, everyone. Thank you for joining us today. Welcome to this webinar, which is part of the ongoing series hosted by ISO Technical Committee 347, Data-Driven Agri-Food Systems. My name is Andres Ferreira, and I will be the moderator for today's session. I'm chair of TC 347. So about the webinar series, the series is designed to explore key technical areas where standardization can support innovation, sustainability, and interoperability in agri-food systems. Today's topic, AI in agriculture, what's really happening and why standards will never be the same, relates to a critical area where shared standards could help connect diverse actors, from farmers and researchers to technology providers and policymakers. Yet our understanding of the nature and scope of those standards is still incomplete and evolving. Hence the need for discussions like the one we'll have here today. ISO TC 347 is a new and ambitious committee working to develop international standards that enable trustworthy, inclusive, and effective use of data across agri-food systems. This webinar is part of our commitment to transparency, engagement, and inclusive participation in the standards development process. Today, we aim to introduce key technical insights related to the topic, to highlight how this topic connects to standardization opportunities, and to show you how you can actively participate in shaping upcoming international standards. We're very fortunate to be joined today by Dr. Christian Henning, who will lead us through the discussion. Let me briefly introduce Christian, who's the CEO of PERMA Robotics, the chair of Germany's Mirror Committee to ISO TC 347, and also the convener of our Ad Hoc Group 5 on annotating agri-food systems data for use with AI. Dr. Christian Henning originally studied medicine, worked as a pediatrician, and conducted intensive research on allergies, autoimmune diseases, and how environmental factors affect human health. At 25, he founded his first biotech company. Today, he has launched 6 firms in the biotech and agtech sectors. His focus is always on digitalization and automation. He holds more than 30 patent applications and continues to seek innovative solutions for resource-efficient agriculture that can balance food security with the preservation of our planet's life support systems. He's been programming since the age of 14, his preferred form of expression. His vision is a standardized, open Android for agriculture that will allow new forward-looking products to be built on top of it. To realize this, he heads the German delegation to ISO TC 347, Data-Driven Agri-Food Systems, and is an active member of the Linux Foundation AgStack initiative. In 2025, he was honored as one of Germany's top 30 change makers in agri-food. So with that, I'll now hand things over to Dr. Christian Henning. Christian, the floor is yours.
Thank you, Andres. Thank you very much for all your help and for the moderation. And thanks for having me today. And thank you to the audience of joining us for this, I think, very interesting session, because AI is something that touches us all. And I'd like to kick off with a statement from the audience that was submitted prior to this webinar by one of the registrants. And she or he stated that it seems like there is a new updated AI being released every few weeks or months, much faster than a standard can be created and adopted. And this is the perfect framing. We don't need to talk about language models or vision AIs, because this gets outdated so fast, and we as standardization bodies need to look ahead, which is quite difficult, I agree. But we have to see how the world will be within the next 5 years in the AI revolution, and what standardization can contribute there. So let me take you on a journey. Let me take you on a vision, how the farmer's workday can be in a not so distant future if AI is developing it at the speed that we see today. The farmer works closely with a farm management AI that oversees his farm and helps to plan and to execute things. So at 6:30 in the morning, automated drone flights take place that do disease and yield checks. Based on those drone data, the AI is selecting robots that do the appropriate fertilization or herbicides and start working. At 10, the AI checks the farmer's market and suggests harvesting and selling. So what is good to harvest today and to sell today because there is a demand on the market. And based on the farmer's decisions, at 12, the robots start harvesting the required amount and prepare the harvest for shipping. This, if it would happen and it would be accessible to all, could be a major force for democratizing agriculture. If it happens, we will have those two components of an AI-driven farm. We will have a farm management AI on each farm, and we have physical AIs that drive the robots. The farm management AI needs access to all relevant data sources. Let it be weather, let it be what happens on the field, what happens on the farmer's market, how are the financials doing. So all the relevant data need to be accessible for this farm-specific management AI. It needs access to all the on-farm robots. It needs to communicate with the farmer and based on the information coordinates the work on the farm. The physical AIs, they need to communicate, so the robot AIs, so to say, they communicate intensively with the farm management AI. They take tasks from the farm management AI and execute them. And they collaborate with each other. So why will this become possible now? Why is this quite realistic? I know that some of you ask, please give a short overview of the history and future of AI for those that are not AI native. So let's have a look what happened in the past and what might happen in the future. The ideas not only to replace the human work power by machines, but also replaced human brain by machines or AIs is quite old. So Alan Turing already in the 50s started to think about how to simulate human intelligence and machine learning. Within the 70s, 80s, 90s, people tried to generate rule-based systems, statistics, programming to generate artificial intelligence, but nothing really happened. So this is what we retrospectively today call the AI winter. So between 1970 and 2000, nothing really happened that we would call retrospectively today artificial intelligence. Then something happened that generated what we see today, this AI revolution. And this was, that's a German chart that I found from a statistical outlet. The power of the supercomputers increased logarithmically. So we suddenly had enough computing power to let computers generate artificial intelligences. And one of the guys that really did a lot in this AI world and got the Nobel Prize last year, Geoffrey Hinton, said, sometimes I think it is as if aliens have landed and people haven't realized because they speak very good English. So even Geoffrey Hinton doesn't really understand what the AIs at the end of the day are about, because they acquired, at the beginning, everybody thought, okay, we put in a lot of data and we do language models and people work this way. And then they suddenly have seen that those AIs developed so-called emergent abilities. Suddenly they could calculate, suddenly they could generate images. And so the AI today is a combination of many different technologies that are able to understand things, to generate things, and to steer things based on a network of neurons that is extremely big in the internet. What happened within the last month? So when I presented data in last September, we had the first AI. If we would make an intelligence test, an IQ test, that would have an intelligence quotient of 120. In May 2025, you can see a lot of those models are appearing, and already the first ones approach 135 IQ points. So this is just a surrogate marker that you can see how fast this development is. And as the person at the beginning said, it's changing every week and every month. Yeah? And you can build a company based on an AI model, and it gets outdated the next week. Yeah? So it's difficult to judge what will happen within the next few months. But it looks like that we are still on the right track, as was described in this paper, it's so-called situational awareness paper from Leopold Aschenbrenner. If you want to have a look at this paper, please use the QR code in the bottom right. It is predicted that the AI models will be that intelligent, whatever it means, by 27, that they will start to improve themselves. So they get more and more capable and more intelligent. And by 27, 28, they might be at a stage where they can improve themselves at a rate that, again, we don't understand. And looking at today's data and the predictions, it's quite realistic that this will happen. Yeah, that we will have so-called super intelligence or singularity or artificial general intelligence within the next 5 years. And after this AGI step, it's likely that the AI will write standards for us, and we will not write standards for the AGI. If we look at the capabilities of these models today, it's always good to look at benchmarks. There are existing dozens of benchmarks in the internet that show you how good certain AI models are in regard to certain tasks. And if you like to know how good it is in agronomy, I recommend to use the link on the bottom again, where you will find an agronomy benchmark that tests a lot of agronomy capabilities. And if you look at the first row, that is data from April, I guess. Yes, it's April. The model there, Gemini 2.5, which today is already outdated, had an overall score from over 90%. So the likelihood of answering an agronomical question the wrong way it's below 10% already, and it will even increase over the next years. So what I showed you so far is AIs have sufficient general knowledge. So what is missing? Could they take over? Could we let them steer our farms? Let's look at this in detail. Let's first look at the envisioned farm management AI. For a farm management AI to work, real data interoperability is needed. That's something that we discuss not in the AI world only, also in our everyday's work at the ISO TC 347. Data interoperability is this is something that we are talking about. So we need to connect data sources, and we need to connect and map those data sources to each other, that we can say, okay, this means 10 kilogram of fertilizer, and it's the same as another data system from the outside means. So this connection and mapping is extremely important for the AI to work and to connect all the data sources to make decisions. At the moment, you can be happy because there's a huge gap between the AIs and the real world. So there is no connection to the local context. So it has a lot of general knowledge, but it doesn't know what happens on your farm. Yeah, there is no connection that you could use today. So this connection is the important step that needs to happen somehow. So we need to digitize information from the farms, so make it accessible for computers. Let it be a camera, let it be a water sensor, let it be a PDF, let it be a rain sensor. And this digitized information needs to be connected to the AI brains. And the other way around, if an AI wants to steer something, it needs a structured access to actuators, so to steer a drone, to steer a robot. And there is slowly forming standards about how this could be done. So API, which is called Application Programming Interface, is already existing in the non-AI world. It's a way to describe how to access data from the outside. Last December, Anthropic, a well-known AI company, came up with the Model Context Protocol, which is a standard how you can connect those digital worlds with AIs. And at the moment, OpenAI and also Google adopted to MCP. So maybe this is the standard that forms on how to connect the real world to the AI world. So in case the farm manager, the AI farm manager needs access to the real world, which it has to have, it will ask you, how can I connect to those data sources that I need? And how can I map the data sources to each other? And we can ask, do we need standards for this? Or let me put the question around. Can we connect and map without standardization? So let's just test it. I have brought with me some use cases that we did within the last months to show if this is possible. So let's start with a very, very simple example. So on the left, we have an Excel table, as every one of you has, which has water data. So this is a real world example. This is data from some different sampling points of water, and there are different parameters. On the right, there is another system that exactly had the same type of data, but in a different structure. So the question is, would an AI be able, without standardization, to match those two data sources? And the answer is yes. So the AI models, like you can try it on your own. Take a standard OpenAI O3 model and then upload an Excel file and upload a JSON file and then tell them, please match. Yeah? The AI models are able to read Excel files already, and they are able to read JSON files. And by reading the data, they found out, okay, we have this key mapping here, and it could match those two different data sources. So it is possible to do this connect and map without using an official standard, but it's a gamble. In this case, it worked. In other cases where you don't understand what's inside the data as a human, the AI will also not be able to be to match the data. But in this case, we had a success on the first try. Let's go to a more complex example where we had standards in place. So in this project that we did for the Honduran coffee growers, so smallholders in the global south, we have been asked to connect different stakeholders, so the coffee growers, the Linux Foundation XStack project, the FAO WISP project, and the European Union, to report data from the coffee growers to the European Union, because starting next year, you have to report for each coffee bean where the bean came from and if the bean has been harvested from a deforested area or from a non-deforested area. So here we had to connect multiple data sources to each other, and we had the chance to use a standard because the data sources provided a standardized interface, which in this case is OpenAPI specification. OpenAPI specification is a standard that was drafted under the Linux Foundation, which describes, as you can read here, how, let's say in a simple words, two internet websites can exchange data. So all the partners had OpenAPI specifications. So this is quite nerdy, but you can see that the structure looks quite similar. On the left is the OpenAPI standard of the Linux Foundation XStack, and on the right is the interface from WISC-V. So we handed those interface descriptions to an AI and let the AI generate the connection between the data sources. And it worked perfectly. So the AI was able to generate the code, which was 100% correct and was able to connect those data sources. But when we tried it in the real world, we found out there have been errors. It didn't work. Yeah? So again, fail on the first try. So why? The reason was that the people didn't adhere to their own standards. So the standards or the implementation of the standards were different to the one that was given in the description, in the OpenRP description. Or they changed something in the interface without updating the definition and the description. So in this case, it was a standardized way to describe how an AI could access data, but it didn't work because it was outdated. So taking these two examples together, an AI can automatically perform a connect and map, but it's a gamble. To change this, I think it's my personal impression, we need to standardize it, but the right way. So we need to define how an AI can automatically connect to data sources assuming access is granted. Yeah? So we will always have standardized accessing rules that an AI will not be able just to go behind a firewall. Except the AI has the API key or the access data. We need to define how an AI can then automatically map data across sources. So once it gets access, it needs to map and understand data. And therefore, we need to define, in my opinion, minimal requirements for data to be understood by AI. Our own trials said it's sufficient if you give a plain text definition of what the data is about, which unit the data is. This 10 gram or 10 kilogram or 10 liters? So you need a sufficient plain text description of each data source and each data part. And then the AI will be able to understand the data and make sense out of the data. And that's one of our learnings from our experiments. We need to ensure a continuous monitoring of the AI for any changes. So the AI needs to make sure that the interfaces and the data sources, if they are changing, they need to be informed and they need to change the way to access it and to understand the data. So this, in a nutshell, is what I think an AI needs in the future to work with data. And if you do this, if you have an automated access management and an automated understanding of the data inside the data lake or the data repository, you can directly talk to your AI farm management system in plain language. And this is something that we also already did. So if we have this structured access to all the needed data for the AI, if we have a structured understanding for the AI what the data means, we can just do this one. Yeah, we can ask for a German farmer. This is a real world example. Yeah, when is the right time to apply a fungicide to winter wheat in the coming days in a region in Germany, taking humidity and rainfall into account? Which product would you recommend in terms of price performance with a focus on controlled rust disease? And that's all. And then the AI comes up with picking the right day. So this was an example from April. So it looks up what is the weather forecast, and it understands what it means for your task, for the fungicide application. And it tells you which is the best day. Yeah, so it says on Monday it is the best compromise of warm speeds uptake and dry weather. So I never have seen such a detailed recommendation from any human source, to be honest. And every farmer we show this says, wow, I've never seen something like this before. So this shows you how the power of such AI systems is once they have structured access and they have all the knowledge already built in. So this is the picking the day, and then it comes up with the best price for performance for Rust in 25. So it knows all the available options, the pricing, the costs, and it says, okay, this is the best one and this is a good alternative. So I guess this shows you totally the power of AI in the future, and also the way it could really democratize things, because if it's accessible to all, everybody could use it. So this was the AI in the farm management system. And as you remember, there's a second part, which is called physical AI, which is putting such AIs into robots. And this is the next frontier for artificial intelligence. And again, the race is ongoing. It happens already every day. And NVIDIA is leading this race because they already published an AI model, which is called World Foundation Model, which means that this robot not only understand language, they also understand our world, our physics. Yeah. If I'm dropping an apple, it will go down. So this is something that is baked into those World Foundation models, and they are running now on the first robots. I'm sorry for the color, but if you look below on the left, you can see the playground where you can try this out is called Cosmos. So if you go to NVIDIA and Google for Cosmos, you will find playgrounds where you can try out such World Foundation models. And what happens there is, based on the sensors that are built in most of the cases, it will be cameras, but it could be also LIDARs or radar sensors. It's percepting the world, and it's taking in those tokens from the real world. And then they take in commands by plain language. They're like, here, pick up the piece of toast from the toaster and place it on the white plate to the right of the toaster. So it will understand what does it mean? What is a toast? Where is the toast and where do I have to put the toast? Because it can percept the world as it is. And it can generate action tokens that steer the robots. So we will have end-to-end AI for those robots in the future. And my prediction is the following. So the first generation of robots that are now on the fields are more or less software controlled with small AI models like an image recognition model baked in. And those ones will have their maximum usage within the next 2-3 years, and then will be replaced slowly by intermediate robots that already have bigger AI models running on edge or in the cloud with direct cloud connection. We are, as Perma Robotics, built such robots already that understand what's going on outside. And by 2030, I can already predict we will then have end-to-end AIs where we train those robots to harvest things, whatever. Those robots, I guess, were only available in the first world at the beginning, because you need a lot of infrastructure to run such robots. So I'm not sure if this is democratizing things today, but maybe in the future this will happen also, that the robots get shipped all over the world and will do the work where peoples are not available. Here in Germany, we have an increased request on robots just because there are not enough people to do the work anymore. So this is my prediction what will happen for physical AI, and I hope you can see this video here, that our robot is just understanding that it is grassland and that there is no danger, and it just drives there. If you would just take an old robot that has a LiDAR or radar interface, it just sees there is something, but it will not drive because it doesn't know is it dangerous or not. And this shows you how physical AI will interact in robots in this world. So as a summary, in the future, we will not write standards anymore after the AGI step that I showed you will happen within the next 5 years. That's quite provocative, but it could happen. Before this happens, and if we want to use AI, we need to standardize how we as humans provide information to the AI. We today have the chance to make sure that those AIs act in certain alignments that we call responsible AI. Today we have the chance. What will happen after AGI stage, we are not sure, because AGI will improve itself. But as of today, we still have the chance to steer how AI will develop. The data that we provide to the AI will be more valuable if it's standardized. The more standardized the input, the more effective AI-based FMIS and robotics will become. But to achieve this, we as humans must constantly follow the standards we set ourselves. So this is what we have shown in the experiments. You can draft a perfect standard. If nobody is adhering to it or adhering at it only 85%, the AI will also fail. So I guess it has to be a very intense interplay between standardization, but at a very high speed at the moment to achieve what we want to achieve. There is a lot of work already ongoing. There is an ISO TC that handles AI, and there is already published in 23 ISO 42001, which is called Information Technology, Artificial Intelligence and Management Systems. And there are a lot of AI standards that will come up that are not specific for the agricultural sector, but as I showed you, maybe we don't need specific standards for the agricultural world in the AI age. However, I'm not sure. And that's where AHG5 comes into play. AHG5, we did nothing within the last half year, and it's dependent on what was shown you first. The speed of development is so fast, it doesn't make sense to act at the moment. But now slowly we can see what happens and in which direction the AI will develop. And therefore, we will now start working on this in the next half year. I suggest to collect more use cases for this AI interoperability in agriculture and test in a sandbox to find out, is this guidance that we give, that we need a good definition of the connection and a good definition of the mapping sufficient, or are we missing something if we try to make data interoperable in the where we need more standardization? We want to generate guidelines on how to shape the standards for an AI-driven future. So the work of ISO TC 347 will draft a lot of standards, and we will guide those working groups, if they want it, how those standards have to be aligned with an AI-driven future. And That's what I said in my last slide. We want to find out if we need agriculture-specific AI standards or if we could contribute to the IEC JTC SC42, which is dealing with the AI standards in an independent way. I'm happy to have you in this AHD5 as we will now take up speed and work with the AI in the agricultural world. If you like to participate, there is a lot of possibilities to participate using your national committees, and later you can also participate in several meetings and working groups. But I guess this is a point where I can hand over to Andres because he is able to guide you to the official possibilities of participating much better.
Thank you, Christian. So as this slide shows, most of the work in TC 347 happens online in groups like AHG5 and the AG3 that I mentioned in the chat. Twice a year, we bring everyone together because there's a lot of valuable cross-pollination that's going to happen in those situations. We have one of those big meetings online, and then we try to have another one in person with some hybrid participation, but primarily in person, in what someone described following our first meeting of that sort back in March as a once-in-a-lifetime networking opportunity. Let's make it a once-in-a-year networking opportunity, which will happen again in March and take about 4 days. The working groups, ad hoc groups, advisory groups, and so forth meet more often, but they set their own schedule. As Christian said, there's more than one way to contribute. One is through your national standards body, where you're named a member of your country's mirror committee, and through there to wherever you fit and want to participate in TC 347. You can participate directly in the work of developing standards, and you can also help your country vote on the different ballots that come up for decisions. And another way in which you can participate is through a liaison organization, like, say, the International Society of Precision Agriculture, or Ag Gateway, or GS1, or different liaison organizations that we have. In that case, you can also participate directly in the work, which is the most important part, but you just don't vote. Now, please contact us with questions. You have an email there. Christian put his contact information in the title page as well. We have a LinkedIn page. It's being shown here as well. And we have a main ISO page that shows you what kind of work or groups are going on right now. So I invite you to join us. If you want to know more, just reach out. And with that, I will one more time thank Christian for his great presentation and open it up for your questions and comments, which is really the most important part. So we have a first question from David Smart, who says, I can imagine scenarios where the AI can advance things far too quickly compared to creating a standard. But do we expect the AI to interact with other AI to develop their own standard? And he provides some classic examples, such as the 3-point hitch, or an electrical interface, or the form factor of a traction unit compatible with something else. So, Christian, any thoughts about that?
Yeah, so we can already now see the first drugs that have been developed by AI being tested in preclinical trials in medicine, where the scientists say they would never have been thought about such a solution. So AI is quite creative and can think about things that we never thought before. And it might come up also, if we ask for it, with standardization, saying it would be wise for you to be able to put any implement on any tractor to do it this way. The question is if we as humans like to do it. Yeah, it will be more a philosophical question. Who is the leader? Who is the decision maker? Yeah? Will it be the AI, or will it be only give us new ideas and we decide where to go. So I would be curious just to try out to come up with new solutions with new standards. And but as long as I can foresee, we will be the one that decide if we adhere to it or not.
Thank you for that. Then we have another one from Edward Barnes. And Ed says, excellent and informative presentation. So do I understand correctly that the standards focus in an AI-enabled world will be focused on data definitions and data format will be less important, thinking that it already is less important?
Exactly. So what Andres did in the preliminary work to ISO TC 347 is they looked what's existing in this world, having a special advisory group. And they found out that there are about 600 different semantics existing in AgTech in the world. And it's unlikely that everybody will throw away its internal standard and adhere to a common standard. What is much more likely is that we want to make those existing 600 semantics talk to each other. And as I showed you, this is possible if those semantics provide sufficient information, what it means, what the structure is, what each field means, how it is stored, how you connect, which database type. It's exactly as you said. My vision is that we will more focus on standardizing about the meaning of the data and less on the structure.
All right. Thank you for that. Okay, let's see. I have a question for you. In addition to setting up the mechanisms for interoperability, right, for two systems to be able to understand one another, where one of these systems is an AI, we also need some kind of way of describing what the requirements of decisions and so forth are, right? And this, by the way, is a veiled reference to other work in TC 347 regarding a thing called data product specifications, by the way. But the thing is, like, you gave an example of a great example of a workflow leading to recommendations about different products, for example, right? But it's often the case that when looking at different products, you are looking at, say, the active ingredient, and a huge difference in the behavior of agricultural chemicals is represented by the inactive ingredients, right? So the things that make the active ingredients stick to the leaves and not just fall into the ground right away when it rains, and the things that stabilize it so that it doesn't clog the nozzles of your spraying equipment and precipitate into the tank just because the water was cold or its pH was a little off. So it's important for an AI to know these things when you are making recommendations. But sometimes the tool maker, somebody that's just looking at, say, prices and active ingredient concentrations, wouldn't know that this is a big deal. So how do you think we're going to be able to deal with this matter of ignorance about the world? We have a great question about hallucinations, right, which is a separate topic, but or I guess linked in some way. But how do you deal with the matter of ignorance, Christian?
Yeah, I guess it will be important to select for the farmer which alignment she or he attributes to the AI. If you tell the AI, it doesn't matter if the environment survives, I just want to make as much money as I could, the AI will behave differently as if you say, okay, let's take care of this aspect, let's take care of this aspect. You can do a trial on your own by steering the AI to different outcomes, and you will see it will answer differently depending on the alignment you are giving it. So the question is, will we have a general AGI that is open to everyone, like DeepSeek or something like this, that everybody can use and everybody can shape like he or she likes? Or will we have closed versions that have a pre-alignment that will always behave the same? So there is only the chance that money is first or adopting to the planetary boundaries is first. So this will be a very interesting development over the next years. If there are AIs available that look at different angles on your farm. So I have a second company that's called Soil Diagnostics, and we have an AI that is aligned to regenerative practices. And it will steer your farm based on its knowledge to regenerative practices. But that's only one option. You can do it differentially.
All right. Thank you. We have a follow-up comment from Christopher Brewster. Are you concerned about large language model hallucination?
Let me tell you a story. Before we had the first landing to the moon, standard computers did a lot of mistakes. And because they did know, okay, going to the moon, we cannot allow any mistakes in calculations. And I don't know which year it was. They invested a lot of money to stop the hallucinations of this old day computers, and they have been successful. And I guess we will see the same here. So we will see over the years a dropping on what we call today hallucination. And it will drop, I'm sure, drop below the mistakes that we as humans do. So it will be in between fixed algorithm computer that has no mistakes by definition and us as humans. So today, I would say it's already close to humans, the degree of mistake, but it's not superior. So I'm not afraid of hallucinations because I know they are there. Right? It's the same as we as humans. If you ask a human about a direction, there could be also hallucination about where to go. And I know that they will drop to a level that there's trust. And trust is the most important thing. Yeah. There will be a day when we trust AI more than humans. This day has not yet come. So I do an experiment very often in my lectures where I ask me as a doctor giving a bad advice about a disease, and the AI gives a second advice, which is much better already today. And then we ask the audience whom you trust. And the answer is always, we trust you as a human. Although objectively, I'm doing mistakes. Yeah. And therefore, today we will trust humans more than AIs, but there will come a day where we will trust AIs more than humans, I'm quite sure.
Thank you, Christian. A little bit of follow-up, and in the spirit of full disclosure, one of the underlying motivations of TC347 when setting up Ad Hoc Group 5 in the first place was that developing or moving towards a formalized approach towards annotation of agri-food systems data for use with AI would help reduce those hallucinations. That I think we're confused now by the great results that we're getting in LLM assisted interoperability and mapping between different schemas and so forth. But going back to your question about are we concerned about hallucinations? Yes, we are, especially when you have smallholder farmers whose only access to agronomic insights might be through an app on their phone that has an AI model behind the scenes. It's very important that we minimize the possibilities or probabilities of error. So thank you for that. We have another question from Julia Bonner-Douay, who was until very recently the chair of ISO's Developing Countries Committee. And she always asks great questions about the impact of technologies on people in developing countries and how they can leapfrog stages to use these technologies gainfully. So what she says is that this was interesting and there would be a great deal of background capabilities needed by the developing countries and, countries in the global south in general to catch up. So what are the thoughts or plans to support this new possibility? Let me slip in a quick idea and then it's all yours, Christian. So Julia, part of the TC347 vision is that through a stack of standards from ISO and other organizations that have been working on information technology for a long time, that the barriers to entry into being able to develop agricultural technology for growers in the global south is reduced, right? The idea being that we seek to enable through standards-based open source tools like the ones that Christian relentlessly supports and promotes. That way we can enable people to stand on this base of existing standards and tooling so that they can add that value that helps their community, implementing the thing that they know better than anybody else, but easily without having to build everything else from first principles. And Christian, I don't know what you'd like to add to that.
Yeah, me as a private person, I'm working with an NGO that tries to bring this to the global south, and different steps you need to do. First, you need to bring hardware there, that the people have the hardware to work with the internet. Then you need stable internet connection, which, for instance, Starlink, if you like Elon Musk or not, but Starlink is a great opportunity to have internet everywhere. So you need a computer, you need the internet, for sure you need power to do this. And then they need to learn to program. I think this is still necessary because AIs also program. So to understand what AIs can do, they should learn to program, and then they should learn how to use the AI. And that's what we are working on, that they are, at the same time they learn to program, also learn how to prompt an AI. And this is a really, really a big opportunity because the access, democratization to knowledge, to computing power is there. Yeah, and that's I agree with you. This is important that we have a look at this. However, there are the big ones in Germany. AI is called KI, künstliche Intelligenz. So I always say we have two big challenges that start with a K, which is AI and climate change, which is also starting with K in Germany. So we have in parallel the AI revolution, but also the climate change problem that is much bigger in the global south. So I guess it would be great if we use AI to help people to understand how they can cope with the climate change to keep things growing.
Thank you. We have another question from Kapil Dev. He says, can AI be used in tractor telematics and their connectivity platform to enhance features of other platforms like farm management information systems? I want to add a little bit of context here in saying that equipment companies are already implementing AI solutions in the newest machinery, like combine harvesters and so forth, to reduce losses, right? There's an emergent work on enabling the machines to optimize their functions. And also, usually the workflow that leads to being able to use data optimally coming from a machine, usually these break down very badly in the field. So data coming from machines is usually nowhere near as usable as it should be. And that's because the proper reference data of the products that you might use weren't sent out ahead of time to the machine. The machine may or may not have the right field boundaries and so forth, but sometimes the machine isn't calibrated properly. There's a lot going on there. And AI can probably be very helpful to straighten those things out and to help flag problems before they happen. And we have an ad hoc group 7 on enabling insights with machine data that deals very pointedly with this matter of those workflows. But Christian, over to you to add what.
Yeah, there's again a nice story I can tell you about some hundreds of small robots that have been coordinated by AI in China to move a complete huge building. Yeah? So the AI used the incoming data from those robots, coordinated, found out how to optimally steer them to get them in equilibrium, and moved it by a huge, some 1,000 square meters building 50 meters to the side. And this would not have been possible without AI. So I guess once those tool maker and implement maker companies discover how useful AI is in coordinating things, they will, and they're working intensively on it, as Andres pointed out, they will use AI in those platforms and coordinate things using a central FMIS to coordinate work.
We have another question. It could be our last one from Charles Parrish. What recommendations and strategies could you share about using context engineering for engaging with AI? And how important do you think context engineering is for AI response accuracy?
As I said, I'm always saying, sorry for this, shit in, shit out. If you're feeding the wrong context, nothing will happen that really helps you. So the context engineering is the cornerstone, yeah, of using the AI correctly. So you can do this like experiments, leaving out the context, giving the wrong context, and whatever, and you will see the different outcome. So maybe this would be also a good trial for the sandbox to play around with the context engineering and show people how different outcomes could be. Yeah, this I guess we need a lot of examples to get people familiar with this new world.
Thank you, Christian. Oh, we have one more from Rose. Do you have any insights for AI developers who are trying to keep up with standards and keep up with the times as we progress into AGI? And I want to make a plug here for ISO's 42001 standard for management systems for AI that Christian mentioned earlier, that is meant to help organizations implement and organize, the way that they manage AI. But Christian, over to you.
My answer is it will be difficult because the race is really logarithmic. Yeah. And the standards will always maybe be outdated at the time they are published. Yeah, it's a difficult time for standards, and therefore I guess it's necessary that we talk to each other and try to keep up with the race, knowing that we are the slower part of the race.
Thank you. And with that, it's time for us to finish the webinar. So thank you all for attending, and thank you very much, Christian, for this excellent presentation. I want to wish everyone a wonderful rest of your days. Thank you.
Me too. Bye bye.